Alright, so what we're going to talk about next is saddle point in zero sum two-person game. Okay, so in a two-person game, so to understand all the terms in the thing first, I don't know, definition of a saddle point. All right, so before getting to that, we will understand what exactly is the game setup. So what exactly is going on here is that we have two players. One is a role player who tries to maximize his payoff. He is here to win. He is here to maximize his payoff, maximize the amount of points that he can get. And second is the column player who tries to minimize the row player's payoff. He is not here to win. He is here to make sure that the row player or the other player gets जितना कम हो सके उतने कम points मिले. Okay, वो जितना कम करवा सकता है सामने वाले के points उतना कम करवाएगा. All right. And the second thing is that the game is a zero sum. So basically what happens in a zero sum is one player's game will be the other player's loss. All right. Now, what is saddle point? Now coming to saddle point, a saddle point is a special number in the payoff matrix that is the smallest value in its row. So basically in the from the row you will come up with the smallest value, which is the worst case for the row player. It represents the worst case for the row player, and it is the largest value in a column, which will represent the worst case for the column player. Alright, if such values exist, it becomes the final decision for both players. Alright, which becomes pure strategy equilibrium. If this value exists, then the setting is it contains the possibility or the existence of a pure strategy equilibrium. Now, what does it mean in the game? Okay, so matlab what exactly does this thing mean in the game for the game interpretation and the game meaning? So basically, a saddle point means that the saddle point means that both players are satisfied that row player का condition क्या होगा, he cannot get a better payoff by changing rows, and the column player will be that he cannot reduce the payoff further by changing columns. So basically दोनों के लिए best case scenario. All right, so by deviating from that point they are not doing any better, so the result becomes stable. Neither player will want to deviate, and this will be called the value of the game. Now, what is the strategy being used for row player and column player respectively? Also, this question is usually asked for 5 points, like writing a note in your paper, so you can frame it accordingly. Alright, so row player strategy क्या है? Row player strategy is called maximin. Alright, so steps for the row player will be that he looks at each row, he will look at each row in the payoff matrix, and he will try to find the minimum value. That is the worst out that represents the worst outcome in that row. Then he will choose from those values the highest among all. Okay. First, he will find the minimum value from the rows, and from those minimum values, he will find the maximum value. The value will be called maximum, and that value will guarantee row player the best security against the column player. Now, what is column player's strategy? Column player's strategy is minimax, where he will look at each column and find the maximum payoff. Alright, he will find the maximum column wise values, and from those maximum column wise values, he will find out the lowest values. Alright, this value will be called minimax, and it will guarantee the column player that the row player cannot get more than this. Alright, now when does a saddle point exist? A saddle point exists if the value of the both the minimax and the maximum values that we have found, if they are equal, then the saddle point exists. Okay, and this is called the value of the game. This value will be called the value of the game. All right, and this will mean that the pure strategies in the game are optimal. Now, how we find a saddle point easily? Okay, now there's this thing called direct detection rule where we can find it pretty easily. First, we are going to find the row minima, which is choosing the largest value. Then we find the column maxima, which is choosing the smallest value. If both numbers are equal, then saddle point exists. Alright, now that exact matrix entry, the saddle point must be, it should be smallest in its row and should be largest in its column. If they don't match, that means no saddle point exists. Now the some value v is equals to, यहाँ पे जो condition लिखा है, it is written clearly over here, where value v is equals to aij, means that it should be equal to a value in the column such that it is smallest in its row and largest in its column. Now, We have alternative entry characterization, which is written clearly over here. The condition यहाँ पे clearly लिखा है, not necessary that you write it in your paper. If you want, you can. It is a simple condition for a saddle point. Okay, that means the number exists if it looks like a valley in its row but a peak in its column. मतलब valley in its row means it's small value in its row, and a peak in its column means it is a high value in terms of column wise, the way it is situated column wise. So then it is called a saddle point. Now, what happens when no saddle point exists? Then, basically, if the maximum and the minimax values are unequal, then there will be no saddle points. Okay. Then what happens is that there is no pure strategy solution that exists. Then players must resort to playing mixed strategies, and the game value is found using probabilities. Okay, methods like linear programming or algebraic methods will be used. Now, are there any special cases? Special cases as in, is it possible that multiple saddle points can exist? Yes, multiple saddle points can exist. When, if multiple, now what happens if there are multiple equal values of the game and they satisfy the condition of the saddle point, then they all lead to the same value. Okay, same unique value, then multiple saddle points exist and the game is still stable. Now here is an example of finding a saddle point. Now what do we have here? We have this matrix, we have this pair of matrix, and now we are going to find the saddle point over here. Now, finding the row minima. Okay, for row A1 we are going to find the minimum 3 and 1 में से minimum ढूंढना है, that will be 1. फिर रो A2 में से we have to find the minimum, that is 2 and 0 में से minimum ढूंढना है, that is 0. Now from these values we have to find the maximum. Alright, first minimum then maximum, that will be 1. This is our maximum value. Now we will find the column maxima. Column wise, first we have to find the maximum value. What is the maximum value in B1? 3. Maximum value in B2? 1. Now what are the values that we have found? 3 and 1. Now, accordingly, from here we have to find the minimum value. 3 and 1 means the minimum is 1. So, our minimax value would be 1. Now, maximum and minimax values are equal. So, our saddle point exists and the game value is 1. If it did not, then it meant that there is no pure strategy equilibrium. The players will have to resort to mixed strategies. Alright, so that was a video about saddle points. If you liked it, do leave a like, comment, subscribe, whatever it is that you do. Thanks for watching the video. Bye.